All right, so now that I've talked about the report features and generally how reports work, I wanted to discuss depth of knowledge and fluency. And fluency is a special feature of smarter solving that is unique and something that I think really takes data analysis in educational programs to the next level. But before we talk about fluency, I wanted to talk about the concept of depth of knowledge. Unlike older generations of tests, next generation assessments test not just content knowledge, but students' depth of knowledge as well. They're not just looking for procedural skills. They want students to be able to think strategically, to have a more complex and coherent understanding of mathematics. So on this slide, I wanted to introduce Webb's depth of knowledge framework. This is the most widely used framework to discuss depth of knowledge. It's used explicitly by Smarter Balanced Assessment Consortium. It's not used by PARC, although it's a component in how PARC determines question difficulty. And so looking at Webb's depth of knowledge, you can see that Webb has split up question difficulty into 4 different levels, rather skills into 4 different levels. There are some very basic skills in level 1, recall skills, and you can see a lot of the words that are associated with that, drawing, identifying, calculating, repeating. The next level is a little bit more sophisticated and relates to doing skills or understanding concepts. And the words that are associated with this are things like infer, interpret, relate, categorize. The next level, level 3, involves strategic thinking. And here, students will need to construct logic, critique, develop an argument, hypothesize. And then finally, level 4, which is the most sophisticated level, involves extended thinking. It involves connecting different things to one another, creating things, proving things, synthesizing information. And at this point, it's important to understand that there are these 4 different levels. And this describes the sophistication of a question, the sophistication of skills. So you can think of it as something like question difficulty. Old exams mostly had questions that were DOK level 1, level 2, but next generation assessments, in addition to having level 1 questions, there's lots and lots of 2s, many 3s, and some questions that are even approaching level 4 DOK, like performance tasks. There aren't really very many released questions or questions on exams that are true level 4s, but there are a lot that start to approach that level. Do you guys have any questions about depth of knowledge before I move on and start talking about fluency? All right, so understanding depth of knowledge, let's look at how students are evaluated on a typical next generation assessment. So this is sample student results from CASP, which is California's next generation assessment. And a couple of things to note here. Note that there's the scaled score that's set within the context of expectations. Performance breakdown includes not just concepts and procedures, but also problem solving, modeling data analysis, and communicating reasoning. So this is something that's pretty different from math tests that were graded in my math class growing up, where I got from the teacher 80%, 85%. This is something that really it's different. Methods of assessing students are different today. As I mentioned, looking at CASP results, we see there's no percentages, that student scores are given within the context of their expectations. CASP is also a computer adaptive test, which means that different students are given different questions. And in this context, simple percentage results start to become meaningless. In past tests, you could correspond a certain percentage with a certain performance level, but it's not so simple now. So we need to have a metric that provides more insight. We need a next generation metric to prepare students for next generation assessments. So in smarter solving, unlike traditional metrics that show an accuracy for a particular difficulty, which worked well in the old framework, In the new framework, we flip that around. Fluency flips this by providing you the depth of knowledge difficulty for each standard or target that a student can solve reliably. And we define reliably as 70% of the time. The benefit of this is that now you can understand performance, student performance, in the same terms used by next generation assessments, and just as importantly, within the context of expectations on next generation assessments. A percentage just won't do that. Even if you break the percentage down by difficulty of problem, you won't be able to get the same information. And that's a lot more difficult to analyze. So as I mentioned before, fluency is the difficulty of problem, the DOK difficulty of problem that a student can solve 70% of the time. And we place fluency on the DOK scale. The student's fluency updates in all relevant standards and targets after every single problem. So this provides you information exactly as it's happening. I can give you an hour lecture on fluency, and I have done this in the past, but I'll just touch on some of what the basis of fluency is and how we calculate it. It's based on ELO ratings, which were originally invented for chess, but nowadays it's used a lot for other sports as well, and it's something that is comparable in accuracy to methods used in next generation assessments. So it's something that's a little bit simpler than sophisticated algorithms that are used in next generation assessment to provide results. But the accuracy and reliability of it is comparable. And in the context of smarter solving, where skill level is changing throughout the year, the method that we use based on ELO ratings is even superior. So there's a lot of complex math behind this, but the concept and impact isn't that complex. Fluency provides you this information in a simple and elegant way. It's a single metric that's provided in a single report that provides simple color coding to help understand the results. It combines all of these different parameters, difficulty, recency of the question solved, skill level of the student into one meaningful metric that lets you understand exactly where the student stands. And not just that, but the data that we provide is on the standard and target level, and that means that it's actionable. And this is a major difference from how students are provided results on end of the year exam, or even on interim assessments like those from SBAC. They only provide these big, broad categories. If you know a student is having trouble with concepts and procedures, how are you going to do an intervention with them? You need to really understand on the standard by standard, target by target level, where the student stands in order for this data to be actionable. And smarter solving through its fluency metric provides just this.